Hello all. Today I'm going to talk about a general approach to geometry problems. A lot of students ask me how to get started with geometry, or if I'm stuck for a long time, what should be done, or even if I get stuck and I solve a lot of problems, I'm not able to get good at geometry. So what should be the perception that I should take? Personally, I believe geometry is my strongest and the most interesting subject. Let me give you my perspectives. You can also give your comments in the comment section. Let's get started. In general, geometry has three subdivisions. First is the synthetic method of solving. I will describe all three subdivisions of geometry that I wanted to. Then I will give you textbooks to follow, and you can use these ideas to get yourself skilled up in geometry. First is the synthetic method. What is the meaning of synthetic method? Well, you analyze the visual objects or visual geometric objects like angles, lines, triangles, etc. What does it majorly involve? It involves constructions and angle chasing. So, majorly, it involves constructions and angle chasing. Sometimes you should also chase the lengths. Alright, when is it applicable? Its applications include first configurations. Configurations mean like Humpty Dumpty points or bisectors. You can have complete quadrilaterals in a certain configuration. Realizing each configurations in the given configuration is the crucial aspect of approach using the synthetic geometry method. So this requires some experience as well. You have to learn all these ideas like complete quadrilaterals and properties of cyclic quadrilaterals, so on. Only then you will be able to observe. It's not only about learning those conceptually, but also you strengthen those, consolidate those foundational ideas using problem solving. Alright, the second one that where you apply it relies on your intuition. That is, if you're able to predict some 3 points are collinear or 3 lines are concurrent, like 3 lines being concurrent means like this, 3 points being collinear means like this. If you are able to conjecture or identify such behavior of geometric objects, then you may apply your synthetic approach. Now for this, you must draw good diagrams. One of the key ways to do it. Of course, it will get consolidated as you get experienced, but it does not only depend on your experience. You should draw good diagrams, you should pay attention, and you should be quite focused into the configuration. That's why this is known as analyzing the visual geometric objects. So you pay attention while you solve the problem, right? You should not be distracted. So these two are the main places when you start applying the synthetic method. When you identify some configuration, nice configuration, or if you're able to conjecture something through intuition. Alright, let's get into the second method. It is the analytical method. So what is the meaning of analytical method? Well, in some sense, it assigns It is some assignment to each point of the space. So it can be a plane. Sometimes it is a 3D space. So you assign, let's say, pair of values, real values to each point in coordinate bashing. And in barycentric bashing, you assign set of weights, numbers that represent weights with respect to vertices of a certain reference triangle. So it can involve any of such assignment. Majorly it involves analytical derivations. Also it involves 3 parts: complex bash, trig bash, barycentric bash. So if you get strengthened yourself with these 3 types of bashing, it will be helpful for you to carry over the analytical methods. Now, when is it applicable? For example, we saw the applications for synthetic method. When the analytical method could be applicable, it's when you have a perceived estimation of the amount of calculation that you are going to do, and that should be manageable. Only then I recommend you to start with complex bash or trig bash or bary bash. So let's write it down. The application is when perceived calculations are manageable. Let's get with the third method of solving geometry problems. Transformational geometry. So this one is kind of not very intuitive and not taught at early levels of our Math Olympiad program, and even in your school curriculum it's not taught for lower level or lower grade kids. So as the name suggests, it involves transformations. You transform your space under consideration to itself by some function, maybe linear, maybe non-linear. One such example is inversion. Inversion is a non-linear transformation. So we have inversion here. We can have projective geometry. So I can talk a little bit more on projective geometry. This is my favorite method of solving geometry problems because it has a lot of applications. So whenever I have a lot of concurrent lines and lines that go beyond my point of perception, they may tend to use projective geometry, and you know what? Most of the times it gives me at least a claim that takes me towards the solution, but may not be the entire solution. And it may also be homothety. So homothety is a linear transformation. So it involves both linear and non-linear. Inversion is very unintuitive. Inversion is like you be in one space and you invert it and get to another world. So I usually address students that you get from your actual world to the parallel world where you are solving this, and the parallel world or universe is solving the inverted version of the problem. You see, inversion can drastically reduce the complexity of a problem. The inversion might have really simple solutions where the actual problem has a really lengthier solution. For example, proving Ptolemy's theorem. You might be heard of this theorem, Ptolemy's theorem. The proof of Ptolemy's theorem is not at all simple in the actual space or the plane without using any transformations. But if you use inversion, if you invert about the circle, then it is instantaneously true. Alright, we know what are transformations. They are just some function from your space R2 to R2. It can be some other space as well, R3 to R3. Your definition depends on the space. You have to define it carefully. And then you can have these three types. So it involves these three types. Second one, what are certain applications of them? That is, when can you apply these inversions? These kind of transformations. So when again you observe some configurations, you may apply these transformations. Particularly projective geometry, when there are a lot of concurrent lines or when there is an occurrence of harmonic bundle. Harmonic bundles are really nice. Projective geometry talks about one primary thing throughout its discourse. What is that? It is the cross ratio. If cross ratio is -1, we say that those set of points or those pencil of lines as harmonic bundle, or sometimes a quadrilateral, a cyclic quadrilateral as a harmonic quadrilateral. So when you observe those kind of configurations, you tend to use projective geometry. And what about inversion? I usually use it when you have multiple circles passing through a point, or I just use it when I'm completely stuck. When I have no way to proceed further, I tend to use inversion. So in the last video in which I discussed about an IGO problem, I felt using inversion can give me a result just because I was stuck. So you can refer to that once. Regarding homothety, if you see some diagram that is similar to the other diagram, just with a different scale, you may use it. So these are the three methods that I would suggest you for approaching a geometry problem. Notice, no method is larger or smaller than the other. But one point I would like to suggest on synthetic geometry. So it's a remark that not all problems can be dealt with analytical or transformations. Sometimes some problems might seem unapproachable with these two methods. But in most of the cases, like approximately more than 95% of the cases, there might be some solution using synthetic approach and a simpler solution using synthetic approach. But this might be hard to find. So I appreciate if you can learn some level of synthetic geometry, learn in the sense, learn the concepts as well as learn how to apply it. So learn some level of synthetic geometry and focus on all three methods simultaneously, but you should not skip synthetic geometry. Based on your interest in for the general purpose of for the general purposes of solving geometry problems, you can use any method of your interest. It is up to you. Just do not skip synthetic geometry completely. You can learn up to some basics. What are the books I would suggest? Here is the list of textbooks that I would suggest for these three methods of geometry. First one, you start with something gentle and simpler. That is Challenge and Thrill of Pre-College Mathematics. This is by C.R. Pranisicher and others. Secondly, if you get proficient and skilled with this book, proceed to the next, which is Euclidean Geometry in Math Olympiads, with an acronym of EGMO. It stands at the forefront of the Math Olympiad preparation. This is by Ivan Shin. A very good and comprehensive book for all the three methods that we discussed. Once you are done with these two, start solving random contest problems. You can get it from AOPS. This is the third step I would suggest. Random contest problems. And spend approximately a month of time solving using synthetic separately, and another month for analytical method, and another month for transformation method. If you do that and try to apply all the ideas that you learned, only then your learning will get consolidated and you will be able to apply whatever you have learned. Otherwise, whatever you learned might not be easily applicable when you start solving the problems. So consolidate your foundation understanding and solve random contest problems from AOPS at the end. So if you were then thinking about getting into IMO-TZ camp or IMO training and IMO level exams, then each of these three methods will play a crucial role in your preparation. Do not skip any of them. If you're doing it for general purposes, then I would say do whatever you would like from these three, but do not skip completely the synthetic method, because some problems are usually unapproachable with these two, analytical and transformations. If you have any other ideas or questions, you may put in the comments. We will answer it. Thank you for watching, everyone. Bye.